Hello students, myself Amruta Patki from Modern College of Engineering. Today we will see the torque slip characteristics of the three-phase induction motor. Now basically the torque slip characteristics are divided into the three different regions. That is, first one is the forward motoring, second one is the plugging, and third one is the regeneration. So forward motoring means what? The forward motoring region corresponds to the value of the slip between the 0 and the 1. Plugging, the motor is said to be in the plugging, operates in the plugging or the counter current braking mode for the value S is greater than 1. And for the regeneration or the generating region is that the slip needs to be negative over here, and its value lies between the 0 and minus 1. So the figure shows over here is the torque slip characteristics of the three-phase induction motor. It is basically operated into the two regions. That is, first one is the stable region and the another one is the unstable region. We will see in the next slide the further characteristics. Now, first we will see what do you mean by the forward motoring region. Now, as we had seen in the last slide, the value of the slip lies between the 0 and the 1. So, the forward motoring region is roughly divided over here into the two regions, that is, low slip region and the high slip region. The torque equation of an induction motor is given as Ks E2 square R2 upon R2 square plus Sx2 whole square, where K is the constant which is given by 3 upon 2 pi ns, where ns is the synchronous speed in RPS, S is the slip, E2 is the rotor induced EMF, R2 is the rotor resistance, and X2 is the rotor reactance. So in the next slide we will see what do you mean by the low slip region and the high slip region based on this equation. So low slip region means what? So previously we had seen the equation, that is T is equal to Ks E2 square R2 upon R2 square plus Sx2 whole square. Okay, so in the low slip region the value of the S is very small. So due to this the term Sx2 square is also small as compared to the R2 square. So that can be neglected. So if the denominator can be neglected, hence in the low slip region the torque is directly proportional to the slip. So as the load increases, speed decreases, increasing the slip. This increases the torque which satisfies the load demand. So as from S is equal to 0 to S is equal to Sm, the low slip region is there. In that the torque is directly proportional to the slip. So here the nature of the graph is linear. The yellow line indicates the low slip region. Next is the pull-out torque or the breakdown torque. The maximum torque is obtained at a condition when slip is equal to maximum slip. So the maximum torque is obtained at S is equal to Sm and is called as the pull-out torque or the breakdown torque. So if the load torque increases beyond this pull-out torque, then the induction motor will be pushed into an unstable region and finally come to a standstill, that is stop rotating. Okay, so the red line indicates when S is equal to Sm, the maximum torque is obtained. So this torque is known as the pull-out torque or the breakdown torque. The third region we have to see is your high slip region. In this region the slip is very high. Again we will consider our torque equation, that is T is equal to Ks E2 square R2 upon R2 square plus Sx2 whole square. That is, the slip value is approaching to 1. So here it is assumed that the term R2 square is very small as compared to the Sx2 square. So in the high slip region the torque is inversely proportional to the slip. Hence its nature is like the rectangular hyperbola. So over here the red line indicates the high slip region and the torque is directly proportional to the torque is inversely proportional to the slip. So as you increase the slip, the torque decreases. Now when load increases, load demand increases, but the speed decreases. Now as the speed decreases, the slip increases. So in high slip region, torque is directly proportional to 1 by s. Torque decreases as the slip increases. Okay, so other regions of the operation, that is the generating mode and the plugging. For the generating region, the slip needs to be negative and its value lies between the 0 and the -1. So if the rotor speed is higher than the synchronous speed, that is n is greater than ns, so such region of operation is known as the generating mode. However, in this case, the rotor and the rotating magnetic field both rotate in the same direction, and the maximum torque in this region is obtained at a slip s is equal to -sn. Then next one is the plugging. So the motor operates in the plugging or the counter current braking mode when the value is s is greater than the 1. So for the value s is greater than 1, the n must be negative and the synchronous speed and the rotor speed must have the opposite direction. And this is achieved only by interchanging the two phases of the stator supply. Thank you, students.